Let's try to solve weekly contest 404. Here is the first question. Maximum height of a triangle. Mm, You are given two integers red and blue representing the count of red and blue colored balls. You have to arrange those balls to form a triangle such as the first ball. Okay. Also, the balls in a particular row should be of same color and adjacent rows should be of different colors. Okay. 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 Got it. So first row would be one. First row should have one ball. Third row should have three balls. There are five balls. Okay. And two, four, like that. 4 and 9. Okay. Red 10, blue 1, output is 2. Okay, okay, got it. Let's use Python. Yeah, mini and maxi is equals to minimum of red comma blue, uh, minimum of red comma blue, and maximum of red comma blue. Now we should take odds from, no, or not always odds, right? So 1, 3, and then 2, 4. It should be okay. Let's try to fix the number of levels for level in range. mm, let's say how many number of levels we can have. This would be maximum mini. Not really. Maximum maxi. Just one. Let's do that. And for I in range uh, level, if I plus 1 modulo 2 uh, odd plus equals to I plus 1, else even plus equals to I plus 1. Let's declare odd and level here outside. Let's declare answer as 0. Right. Now if minimum of odd comma even less than equals to mini, and maximum of odd comma even less than equals to maxi, then we can say answer equals to level. Answer equals to level. Yeah. Return answer. Let's use example test case and run the code. 3, 2, 1, 2. Let's see. 3, 2, 1, 2. Yeah, we are right. Minimum of odd comma even less than equals to max mini and maximum of odd comma even. Okay, so let's submit this. Yeah, it is accepted. Let's jump back to the contest. So what is the second problem? Find the maximum length of valid subsequence. You are given an integer added nums. A subsequence sub of nums with length x is called valid if satisfies sub 0 plus sub 1 modulo 2. Okay. So the sum parity of the sum of adjacent elements are equal. Longest valid subsequence. So what is the constant? 2 into 2 to the power 5. So parity is equal. That means a0 plus a1 is even. Then a1 plus a2 should also be even. Okay. Uh, this means the parity of A0 and A2 should be equal, and the parity of A1 and A3 should be equal. Okay, so we can take 1, 3, 2, 4. Okay, we fix the parity of the first two elements. Fix the parity of the first two elements, then you can check. Okay, we fix the parity of the first two elements. Okay, so it's odd and even. Then we first take odd, then we'll get even, then we'll take odd. Okay, got it. Let's do it in C++. Yeah. Uh, Integer. Let's say count. We'll take nums as parameter, and integer first parity and integer second parity. Let's integer taken equals to 0 and in as nums dot length. For integer, we don't really need nums in. So the num in nums. If num modulo 2, uh, if it is even, then it should be the first parity. Num modulo if taken modulo 2 equals to 0, then that means it should be the first parity. If num modulo 2 equals to first parity, then to taken plus plus. Else if num modulo 2 equals to second parity, will be taken plus plus. We just return taken from here. We don't need n. Just return max of count nums comma 0 comma 0. Okay, comma count of nums comma 0 comma 1 comma count of nums comma 1 comma 0 and count of nums comma 1 comma 1 should be the answer. Let's run the code. This is complete test cases. 462. Let's take 462. You're right. Now let's take another example so that this is like 1, 3, 5, and 7. This is also the answer should be also 4, right? Yeah. But let's say the parity does not match. Let's say 1, 3, and 2, 4. So we have 1, 3, and 2, 4. Okay. I think I have not 1, 3, and 2, and 4. Let's check. Num 0 plus num 1. Answer should be 2, right? Mm, yeah, let's submit. Accepted. Let's jump back to the contest. Hmm. Same problem, different constants or different variation. What is k here? Modulo k should be even. So our first solution is order of k square. Order of k square into n, not possible. We have to think something different. The first solution is to the fix the parity of the first two elements. So we fix the parity of the first element then. In cube is something which I thought of. Uh, yeah, I think this is solvable in into K somehow. In into K. Hmm. Subsequence of sum of norms of length is called valid if sub zero. Hmm. Longest valid subsequence is 1, 2, 3, 4, 5. Sub zero plus sub 1 modulo k is sub zero. Let's see. E plus b modulo k is equals to a plus c modulo k. Same solution, right? B plus c modulo k. A modulo k should be c modulo k. That is the only a constant. That is the only way. Constant. Mm, Positive integer k. We take I and j. So take two parameters I and j. Then from a recursion state I comma j. J means the last taken. Okay, no, we can't do that, right? I comma j. Parity of the next element. It's kind of NQ. Let's say we fix the parities. Let's say we fix the parity. I think the amortized time complexity will be lesser. Let's think. Fix the parity of first one, let's say, is K1, and the second one is K2. We'll go to the and we are at something like AI comma K1 comma K2. We'll first find the next index of K1, next index of K1, and we'll try to find the next index of K2. Next index of K1, and then we'll try to find after that the next index of closest index of K2. So the total amortized time complexity will be lesser if we take this approach, but I am not able to recognize the time complexity. So let's say we have taken all the K1, K2 pairs. In this, okay, let's do this way only. But I'm not sure about the time complexity. Let's define the function again. We don't really need these nums. K1 comma integer K2. Integer I equals to 0 and taken 0 while I less than n. If taken modulo 2, then we'll do equals to 0, then we'll try to find auto u equals to s dot, let's say, state of int. Let's say we'll declare it globally. Let's say s of k1 global, s of k1 and lower bound I plus 1. If u equals to s of k1 dot end, we just return taken, else else not don't need else, taken plus plus I equals to starting. Similar thing will be for taken is odd. Okay, don't need this. Should be k2 and should be also k2. Yeah. Return. We have already returned taken, right? So return, we can return 0 from here. Return taken from here. Okay, this should be integer. Now we can take set of integer is of 1001. Let's say. Now let's clear the array, global array. Is of I dot clear, and we can say integer answer equals to 0. For integer I equals to 0, I less than k, I plus plus. For integer j equals to 0, j less than k, j plus plus. Answer equals to maximum of answer comma count I comma j. Return answer. This is example test cases. Compile error. While I less than n, n should be also defined outside, and n should be nums dot size. N equals to nums dot size. We have to iterate over I. Let me take 1 minute. Yeah. I plus plus. You can do ace of nums I modulo n modulo k dot insert I. Let's run the code now. 4 and 3 should be 5 and 4. Okay, should be 5 and 4. U equals to ace of k 2 dot n. I equals to start u. What is the problem here? Let's print I here. No, you have not printed I, and we should print k1 or and k2 also. In the overall time complexity of this will be n square root n 100. We should not take I plus 1, we should take I, and here we should do static plus 1. Similarly for this, we think we should do like this. Yeah, 5 and 4, you're right. I'll try to submit the code. Accepted, this is accepted. N square root n will be this complexity, because if we have square root n blocks of square root n size, find diameter after merging two trees. There exist two undirected trees with in a name nodes numbered from 0 to m minus 1 and 0 to m minus 1 respectively. You are given two 2D integers ages 1 and 2. Return the minimum possible diameter of the resulting tree. So to find center of one tree and center of other tree, and then add those two. That is the solution. Center of the first tree and center of the second tree, and merge these two. Okay, let's do that. Let's find integer center. Let's take this one, ages as parameter. We can do some kind of for finding center. What is the algorithm we can use? can delete all the nodes which has degree in degree 1, and then all the nodes after that. Okay, just take one thing, vector int number of edges 10 to the power 5, a of 1 and 1 2 3 4 5, and integer degree of 1 2 3 4 5. Now uh, let's say ages in should be integer in should be ages dot size plus 1, because the size of the edges is n minus 1. Now for integer I equals to 0 and I less than in I plus plus, degree of I equals to 0, and we can do ai dot clear. Now we can iterate over edges for integer I equals to 0, I less than n minus 1, I plus plus. We'll do degree of u0, sorry, edges I0 plus plus, degree of edges I1 plus plus, and after that we can do a of edges I0 dot push back edges I1, and a of edges I1 dot push back edges I0. I can do this. After that we'll remove all the edges with degree 1, right? Yeah. So vector of int is for integer I equals to 0. There could be multiple nodes with degree 2, right? So if a tree is like this, this, this kind of, this and this, multiple nodes with degree 2, then we have 4 nodes with in degree 1. We can take any of them as leaves. Okay, so after we find leaf, we can find the uh, maximum distance also, right? You can find the maximum distance also. You can find the maximum distance, right? Mm, so we have popped one element from here. This should not be this. This should not exist. One element from here, one element from here, one element from the here. Okay, this is also right. One element from here, one element from here, one element from here, and one element from here. We should return the maximum distance from here, not really center. Max distance, we can say, with this algorithm. Yeah, I think so. We'll check after that. If degree of I equals to 1, leaves dot push back I, while leaves dot size. What we'll do? We'll also take one count, right? Integer count, number of removals. Leaves dot size should be greater than 1. So let's say like this, 1 2 3, then the distance will be 1, distance will be 1. Yeah, if dot size greater than 1, we'll take vector of int new list. Let's say we'll iterate over lists, uh, live in lists, and we'll iterate over all the adjacent nodes. C of a leaf, we'll do degree of degree of g minus minus if degree of j equals to 1, we'll do new list dot push back j. I'll do libs is equals to new libs. This is lib, degree of lib could be 0 also. Yeah, push equals to 1, then only we push this, and after that we'll do count plus plus. Just return count from here. So do c1 is max distance of edge 1, edge is 1, and c2 as same max distance of edge is 2. Now after we connect these two, we connect something from here. c1 plus 1, right? c1 plus 1, this is 1 and this is 1. We are taking only one edge, so c1 plus 1 plus c2 plus 1. Return c1 plus c2 plus 1. Let's use example test cases. 3 and 5. 3 and 5. Should we submit? Let's submit. Wrong answer. Hmm. Let's draw this tree. 0 1, 0 1, then 0 2, 2 2, 0 to 2, 2 to 3, 3 to 6, 2 to 3, 3 to 6. After that 7 to 8, 4 to 8, 7 to 8, 4 to 8, 7 to 8, 4 to 8, 5 to 4, 3 to 5, 3 to 5, and 5 to 4, like this. 3 to 9. The answer should be 7, and 0 to 1, 0 to 2, 0 to 3. Another one is nothing but 0 to 1 to 3. So here the distance is 1, and here what is the distance? Here the distance should be, remove remove this, 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 this. After remove this, this. After remove this, this. The distance is 1 to 3, 3 4. 4 plus 1 plus 1. If we connect here 0, 1, 2, 3, then what is the maximum distance? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5, 6, 7. Here our answer is 4. Your answer is 1. Here we are taking two edges. 1, 2, 3, 4, 5. Answer should be 5 here, right? Not 4. 2, 3. Number of removals. First one removal, then second one removal, then the third one removal. 4 extra nodes. It should be 4. Then this should be 1. What we are counting? The diameter means length of the longest path. So this is 1, this is 1, this is 5. You should have the diameter. Only one edge case where there are multiple centers. Then the answer should be incremented by 1, right? Length is 1, but here the length is if length dot size is equals to 0, then we can do count plus plus. Should I do that? This is 4 and 5. But here not, it is not 4 and 5. Should be 3 and 5. We can also take at visited of I as 1. No, not really. Don't really need this. Why for the first case the answer is 4 now. This should return as 1. Number of nodes we are connecting to is 4. Number of edges are 5. So one should just print count here. 1. This is returning as 1. This is returning as 2. What is wrong here? I'm not getting it. What is the case? Only this is connected to only one node. If we remove this, then the answer for this test case will not match. 0 to 1. Uh, I'm kind of stuck. If we remove all the nodes 3 7 8 4 and 5, so 4 nodes are removed, the answer should be 5. Why? Because there are 5 edges. If we remove only 0 and 1, then the number of edges it is connected to. What is the difference in these two? I'm not getting it. Okay, so this case is kind of different because we are removing 7, we are removing 1, we are removing 8, we are removing 0, we are removing 2, we are removing 4. Yeah, this is right. When we are at 5, we are removing 5 and 3 in one go. So it is incremented to 4. So it's connected to 4 nodes. So we have something like this 0, 1, and 2, 2, 3. Then this node is removed and this node is removed. The count is 1. This node is removed and this node is removed. The count is 2. Yeah, one is connected to two nodes and two edges. But let's say this is like this 0, 1, 2, 3, 4, 5, 6, and 7. Doing this and this, and this, and this. 3 is connected to 4 nodes and 4 edges. 1, 2, 3. Okay, 4 edges are there, right? What I'm thinking. 4 edges are there. 1, 2, 3, and 4. And 5 and 6. Then should be 6 here. Why 7? Am I thinking some problem differently? Minimum possible diameter of the two nodes. Have I built the tree correctly or not? 0, 1, 0, 2, 0, 3, 0, 1, 2. This is the okay. The longest path could be also possible in the current tree also, right? Longest path could be possible in the current tree as well. That is the point. That is the thing we have missed. Longest path in the current tree. This is the path 1, 2, 3, 4, 5, 6. I think this is the path 1, 2, 3, 4, 5, 6, 7. So the length of the tree is odd, even we can say definitely say 4 plus 3 7. Okay, we're returning the count, right? Should not do this. List dot size equals to 0 count plus plus. Uh, if we have two leaves or multiple leaves, then we can definitely say the size of this will be 2 into 4 minus 1. 2 into 4 minus 1. And if we have only single leaf, then we can say that this is 2 into 3. Hmm. We should return list dot size. We should return this is an array as an array, or we can declare answer outside also, right? So declare answer outside equals to 0, and we can when we are doing this, if list dot size equals to 0, we can do answer equals to maximum of answer comma 2 into count minus 1, else answer equals to maximum of answer comma 2 into count, right? And here we can do answer, we can select answer as 0, answer as we can do answer, initialize answer as 0 here, and we can return maximum of answer comma this c1 plus c2 plus 1, 3 and 5 here. Let's take this example also. This should be 7 now. 357. Let's take another example to verify our claim. Let's say our example is like this: 1, 2, 3, 4, 5, 6, and 7. Then the center of the tree will be 3 or 5, 3 or 5, but that 3 or 5, but we have 3 nodes, right? The distance will be 3 into 1, 2, 3, 2 into 3 minus 1, 5. 1, 2, 3, 4, 5. Let's submit it now. I think this will work. Yeah, this is accepted. So we are done. I will make a separate video explaining this problem. I'm not fully sure about the third problem. The time complexity is n square root n, but I think n square root k, but I think that could be definitely solved in better time complexity. So I'll check the solution of this, and if my solution is the only solution, then I can make the video. Otherwise I will not make any video for that. uh, if you find this screencast helpful, please like the screencast and subscribe to my channel, and also share among your peers. Thank you.